Hello and welcome to our lesson today. Sorry I can't be with you guys. So we're going to do the lesson here on video, and definitely I would encourage you guys to take notes along with the video. I mean, the studies show that when students write down the notes, not just look at them, they tend to internalize them and remember them more. So I really encourage you guys to take notes. So that also means pause the video if you need to write the notes down. But anyway, with that said, we are covering 1.5 sections today. We're actually going to only do half of section 3.2. So what are we going to look at in this lesson? We are going to look at what a system of equations is, and then what it means to be a solution to a system of equations. And then we're going to look at two methods for solving. One is by graphing, and one is by substitution. We're also going to take a look at some vocabulary words, and we'll end with a word problem, everybody's favorite. Woo-hoo! So let's take a look first of all at what is a system of equations. A system of equations is just when you have more than one equation that you're trying to solve and they share the same variables. That's all it is. So what does it mean to be a solution to a system? Well, it has to satisfy, if something is a solution, it has to satisfy all the equations in the system. So we are going to check and see if the point -1, -1 is a solution to the system. And we're also going to check and see if the point 1, 3 is a solution to the system. So let's check it out. So I have it right here. Here was the system. And first let's check -1, -1. So I write down the equation, 4x minus 2y equals -2. I'm going to let x equal -1. And I'm going to let y also equal -1. And let's see if this is true. Well, 4 times -1 is -4. -2 times -1 is +2. And when we add those together, we get -2. And look at that, -2 equals -2. It's a solution, but not necessarily to the system. This point is just a solution to this equation, but that's not good enough for the system. We have to check the other equation also. So again, I'm going to let x equal -1 and y equal -1. And when we work it out, you can see that we actually get something that's false. So -1, -1, this point right here, was a solution to one equation, but not both equations of the system. So it is not a solution because it doesn't satisfy both equations. So let's see what it looks like to be a solution. If we check something like 1, 3, again, we let x equal 1, y equal 3, and when we work it out, you can see that we do wind up with something true. So this point satisfies the first equation. We plug it into the second equation, let x equal 1 and y equal 3, and we work it out, and that is also true. So this point does satisfy all the equations in the system, therefore it is a solution to the system. So that's what it means to be a solution. So now, how do we solve by graphing? The idea is actually really simple. Here is the idea. You simply graph both lines, look for the point of intersection. So the idea is simple. It's just how easy is it for you to graph lines? If you find graphing lines pretty straightforward, then this is pretty easy. If you're still having trouble with graphing lines, then you're still going to have trouble with this. Definitely come in for help. So for instance, if I want to solve this one by graphing, I tried to color code the line so you could see. This yellow line has a slope of 1 and a y-intercept of 1. So here's the y-intercept at 1, and then going up 1 over 1, up 1 over 1. So that's how I graphed this line highlighted in yellow. The line highlighted in green has a slope of -2 and a y-intercept of 4. So here's the y-intercept of 4, and I go down 2 over 1, down 2 over 1, down 2 over 1. That's how I got this green line. They intersect right there at the point 1, 2, so that is the solution to the system. And this is easy enough to do a quick mental check. If x is 1 and y is 2, y is 2, does 2 equal 1 plus 1? Why, yes, it does. If I let x equal 1, -2 plus 4 is +2, which is the value of y. Yeah, that works. So that's all there is to it. So let's look at just quickly this set of vocabulary words, and then we'll look at one more graphing example. I gotta be honest with you. I don't know the reason for this definitions. This is just what they are. We just kind of go with it, just kind of memorize it. When you graph two lines, you can get one of three cases. Either the lines are going to just intersect at a single point, or you end up graphing the lines and it turns out they're the same exact line. So it looks like you're only graphing one line, but there's two. They're just right on top of each other. Or maybe you graph parallel lines and then they never intersect. Well, if they intersect at one point, then you know there's exactly one solution. If they end up being the same line, they're intersecting all over the place, and we say there's infinitely many solutions. Don't say all real numbers though, because if you say all real numbers, you're implying that any point is a solution. But this point right here, that's not on the line. That's not a solution. This isn't a solution. This isn't a solution. This isn't a solution. But this is a solution. This is a solution. This is. So anyway, say infinitely many, not all real numbers. If they never intersect, then there's no solution. So then what does that mean? Well, this is where I just kind of know these words. Basically, if there's at least one solution, we call the system consistent. If there's no solution, then we say it's inconsistent. If they intersect at one point, then we say it's an independent system. If they are the same line, we say it's a dependent system. The word independent and dependent doesn't apply at all when there's not even a solution. So basically, if they intersect at one point, it's consistent and independent. If it's the same line, we call it consistent and dependent. If they never intersect, we call it inconsistent. I don't know a good way to memorize this because these words honestly don't make sense to me either. I wish I could help you on this one. We just memorize it. All right, so you try this one. Try giving it a shot. See, oh, let me move that down. Try solving this. I encourage you, pause the video and try it out. Try graphing these two lines, see what it looks like, find the solution, and also classify them as one of these three. So pause the video right now, see what you get. Okay, hopefully you pause the video. Here's the solution right here. The first line has a y-intercept of 4 and a slope of 1/2. So y-intercept of 4, slope of 1/2. It's the purple line. This equation is in standard form. So the x-intercept is -10 divided by 1, or -10. And the y-intercept is -10 divided by -2, or +5. So here's +5 on the y-axis, here's -10 on the x-axis. I plot them. It ends up making two parallel lines. So there is no solution. We call the system inconsistent, and that's it. So now you are experts at solving by graphing. So let's look at solving using substitution. So solving by substitution, this is probably not going to make a lot of sense until we work at an example, but you got two equations. So the idea is you solve an equation for one variable. If any of the variables have a coefficient of 1, choose that because you're not going to you can avoid fractions that way. So you solve an equation for one variable, then plug that into the other equation. Then you get a value for one of the variables. You plug that value into any equation you want, really, but the one you found up here is usually easiest, and you got your final answer. Let's look at an example, and you can see all these steps. So here's an example, and actually I decided I would work this one out live with you because I think it'll make more sense when we do that. Whenever I do this, so you can follow my work, and I would appreciate it actually on tests and homework if you guys did the same thing so I can follow your work. I label my equations. And so right away, I just called this first equation, equation 1, this equation, equation 2. Now, if I look at these equations, this variable right here has a coefficient of 1. I'm going to go for this guy. I'm going to take equation 2 and solve for y. And you'll see it's really easy. So I'm going to solve equation 2 for y. So -3x plus y equals 36. I'm going to add 3x onto both sides. and I get y equals 36 plus 3x. So y is by itself. And it was really easy because the y was almost by itself already. It had a coefficient of 1, making it look all by itself. We're going to use this one again, so I'm going to call this equation 3. So that was step 1, solve one equation for one variable. Now I am going to substitute into the other equation. I already used up equation 2, so now I'm going to use equation 1. So I'm going to substitute into equation 1. Never substitute back into the same equation. You won't get anywhere if you do that. So the first equation, equation 1, is 2x plus 5y equals 10. But now we know y is 36 plus 3x. So I'm going to replace y with 36 plus 3x. Where there was a y, I now put this. And now I have an equation that I can solve. I'm going to distribute the 5. Let's see here, we get 180 plus 15x. 5 times 36 is 180. 5 times 3 is 15. And we'll combine my like terms. I get 17x plus 180 equals 10. Subtract 180. 17x is negative 170. Divide. X is negative 10. So now I've got one value. Now I'm going to substitute. This is where I can substitute into any equation I want, but I'm trying to find y, and this equation right here that we found in step 1 is already solved for y. That's going to be your easiest bet. So I'm going to substitute into equation 3. Y equals 36 plus 3x. But now I know x is negative 10. So I work it out, and I get y is 6. So there it is. And so my answer, always write your answer as a point, even if you're not graphing. Your answer is the x is negative 10, the y is 6, and you are done. So there's that one. I'm going to give you guys one to try right now. If you need to pause the video to look at this more, feel free. Otherwise, try this one. And unfortunately, I can't pause the recording, so you have to watch me move this up to the other page. But pause the video. I definitely encourage you guys. Okay, I'm going to work this out real quick. I'm going to call this equation 1, this equation 2. I can see that x has a coefficient of 1. I'm going to go for this guy, so I'm going to solve equation 1 for x. X minus 2y equals 4. Add 2y onto both sides, and x is 4 plus 2y. Call that equation 3 so I can refer to it later. Now I'm going to substitute into the other equation, which is equation 2. 3x equals 8 plus 6y. But now we know what x is. X is 4 plus 2y. So I'm replacing the x with what I think it is. So that's 12 plus 6y equals 8 plus 6y. And now I will get the y's onto one side. And, oh, wait a minute. They completely cancel out. And I'm left with something that's never true. This can happen. This just means there's no solution. Yay! We don't even have to continue on with this. So when you're solving If your variables completely disappear and you're left with something that is never true, that means there is no solution. There is no value of x and y that you can plug into both equations and make them true. So there was that example. All right. Again, if you need to pause the video to chew on this a little bit, feel free. Otherwise, I'm going to move on. Let's try this one. And again, I can encourage you guys to pause the video, try it out. Okay, I'm going to go ahead and work it out now. Again, I label these.